Part B says that the equation of the curve is given by y. Part B says the curve is y equals to x cubed minus 4x squared minus 3x. And then question Roman 1 says find the value of y when x is negative 1. So when x equals to negative 1, what is y? We're going to look for y. Now, what are we going to do here? We are simply going to substitute for x and we find the corresponding value of y, because we have this expression where if x is now negative 1, what is y? Therefore, we shall just say therefore y becomes, remember x is negative 1. So where we find x here, we put negative 1. So we shall have negative 1 power 3 minus 4 times negative 1 squared minus 3 times negative 1. Then you press the calculator or simplify. On simplifying here, negative 1 power 3 is negative 1. Negative 1 power 3 is negative 1. Negative 1 squared is positive 1 times 4 is negative 4. And then negative 3 times negative 1 is positive 3. And then you press the calculator and add. Negative 1 minus 4 plus 3. I'm getting negative 2. Let me prove again. Negative 1 power 3 minus 4 times negative 1 minus 3 times negative minus 4 times negative 1 squared minus 3 times negative 1. Yes, it is negative 2. Therefore, the value of y when x is negative 1 is negative 2. That is what part A wanted. That is what Roman 1 wanted. Now going to Roman 2. Roman 2 says find the equation of the tangent and the normal to the curve at x equals to 1. So we are going to use the same curve to find the equation of the tangent and the equation of the normal. But at the point when x is 2, this is the point of, at the point when x is 1, not 2, please. At the point when x is 1, this is our point of tangency. So what do? Our curve is y equals to x cubed minus 4x squared minus 3x at the point when x equals to 1. What can we do there? We need to find the gradient of the curve. After getting the gradient of the curve, that is the same as the gradient of the tangent. And then we proceed with our calculation. So for us to find the equation, to find the gradient of the curve, we differentiate the curve to get the gradient function. So dy dx becomes 3x squared minus 8x minus 3. This is the gradient function of the curve. After getting the gradient function, now we need the gradient of the curve. Therefore, the gradient of the curve at the point when x is 1 becomes, we substitute for x here as 1. We shall have here 3 times 1 squared minus 8 times 1 minus 3. Then we press the calculator. It becomes negative 8. Negative 8. Let me prove 3 times 1 squared is 3. 3 minus 8 minus 3, negative 8. So this is the gradient of the curve at the point when x is 1. At the same time, this is the gradient of the tangent. Therefore, the gradient of the tangent of the tangent is negative 8, because at the point of tangency, where is it? At the point of tangency x equals to 1, the gradient of the tangent is the same as that of the curve. Now, after getting the gradient of the tangent, and we know one point, that is the point of tangency, we can find the equation of the tangent. Because we have m, which is -8, and is the gradient of the tangent. And we have one point on the tangent. Remember, when x is 1, it means y is 0. That is what we should know. When x equals to 1, it implies that y equals to 0. So the point is 1 and 0. Therefore, the tangent is a line given by mx plus c. So we have m, we have x, we have y. So we can find c. That means 0 equals to -8 times 1 plus c. So our c here is +8. After getting c, then you can write the equation of the tangent. Therefore, y equals to, substitute for m and c. m is -8 x plus c. c also, c is 8. And therefore, that is the equation of the tangent. After getting the equation of the tangent, we go to the equation of the normal, because the question has asked for both. But remember, some questions can only ask either for the tangent or for the normal. So be flexible and do what the question demands. Equation of the normal, what do we know? We know that the normal is perpendicular to the tangent. They are perpendicular line. The normal is perpendicular to the tangent. What does that imply? It implies that if you multiply the gradient of the first line by the gradient of the second line, it gives us -1. They are perpendicular lines. So let me call the gradient of the tangent m1. So substituting m1 here, I will have -8 m2 equals to -1. Therefore, my m2 becomes 1 out of 8. This is now the gradient of the normal. Remember, this same point when x is 1, this same point when x is 1 is also a point on the normal line. So therefore, if you have a point 1 and 0, because you know that when x is 1, y is 0, because we are on the x-intercept. And then we have the gradient of the normal as 1 out of 8. Then we can find the equation of the normal, because the normal is a line given by y equals to mx plus c. Substitute x, y, m is there. So 0 equals to 1 out of 8 times x is 1 plus c. If you make c the subject of the formula, c becomes -1 out of 8. That is c. So after getting c, then you say therefore the equation of the normal becomes y equals to m. Substitute for m and c. m is 1 out of 8 x plus c. But c is -1 out of 8. So this is the equation of the normal to discover the point when x is 1. Now, we have come to the end of looking at normals and tangents to curves. But there is an NB that I want you to go with. And the NB is that dy dx is the same as y prime, and is also the same as f prime of x. Okay? So instead of writing dy dx, like in this case, like here, instead of here writing dy dx, someone could write y prime. You say y prime equals to, everything remains the same. Or also instead of dy dx here, someone could use f prime of x. So you could use f prime of x instead of dy dx here. and then we proceed. These three are the same. These three are the same. So if we find it anywhere, y prime, it means that is the same as dy dx and is the same as f prime of x. Okay, so that is what I've just realized that I do not put your attention. So this is the aim of looking at the questions of the normals and the tangents to the curves at given points.